Hello everyone. Let us solve ordinary differential equation applying numerical method. This method is known as Euler's method. Formula for Euler's method is yn plus 1 is equal to yn plus h into f of xn comma yn. We have to apply this formula. First example, use Euler's method to find an approximate value of y. Correct to 4 decimal places for x is equal to 0.1. Given dy by dx is equal to x minus y square. At x is equal to 0, y is equal to 1 and take h is equal to 0.02. Given differential equation is dy by dx is equal to x minus y square. Initial value of y at x is equal to 0 is 1 and we have to take difference between any two consecutive values of x, that is h is equal to 0.02. So using Euler's method we have to find out value of y at x is equal to 0.1. Let us assume dy by dx is equal to f of x comma y and this is equal to x minus y square. x0 is 0 initial value, y0 is 1 and h is equal to 0.02. Applying Euler's formula, yn plus 1 is equal to yn plus h into f of xn comma yn. But f of x comma y is x minus y square. So this is equal to yn plus h into xn minus yn square. Here yn plus 1 is equal to yn plus h into xn minus yn square. Because of this, f of x comma y is equal to x minus y square. If we substitute n is equal to 0 on both sides of this, n is equal to 0 means y1 is equal to y0 plus h into x0 minus y0 square. Substitute these values, hence y1 is equal to y0 is 1 plus h is 0.02 into x0 is 0 minus y0 is 1 its square. So this is equal to, its value is equal to 0.98. This is y1. Put n is equal to 1 in equation number 1 on both sides. Then 1 plus 1 is 2. y2 is equal to y1 plus h into x1 minus y1 square. y2 is equal to y1 plus h into f of x1 minus y1 square. Substituting n is equal to 1 here. This is equation number 1. And here x1 is equal to, initial value of x is x0 is 0 plus 0.02. This is value of h. So this is equal to 0.02. Now put values of h, y1 and x1 in this equation. Hence y2 is equal to, y1 is 0.98 plus h is 0.02 into bracket x1 is 0.02 minus y1 is 0.98 its square. So after calculation using calculator, this is equal to 0.961192. Here fifth digit is greater than 5, so you can change this fourth digit adding 1. So y2 is, approximate value of y2 is equal to 0.9612. To find next value means y3, we have to find out value of x. x2 is equal to x1 plus h. x1 is 0.02 plus h is 0.02 and which is equal to 0.04 and y2 is 0.9612. Now we can find y3. Put n is equal to 2 in equation number 1, then equation number 1 becomes y3 is equal to y2 plus h into x2 minus y2 square. y2 is 0.9612 plus h is 0.02 into, now here x2 is 0.04 minus 0.9612 its square. Use calculator and find this value. This is equal to 0.9435. So y3 is 0.9435. 0.35. Let us find y4. x3 is equal to x2 plus h. x2 is 0.04 plus h is 0.02. This is equal to 0.06, and y3 which is obtained is equal to 0.9435. h is 0.02. Put n is equal to 3 in equation number 1. Then 3 plus 1 is 4. y4 is equal to y3 plus h into bracket x3 minus y3 its square. Okay. So y4 is equal to y3 plus h into x3 minus y3 square. Put these values. Hence y4 is equal to y3 is 0.9435 plus h is 0.02 into bracket x3 is 0.06 minus y3 square, that is 0.9435 square of this. Using calculator we can calculate this value. So y4 is equal to 0.9269. Let us find y5. Before that, x4 is equal to x3 plus h, and you know x3 is 0.06 plus h is 0.02. This is equal to 0.08. y4 is this value and h is 0.02. Using these values, we have to find out value of y5. y5 is equal to y4 plus h into x4 minus y4 square of this. Put these values. So y5 is equal to y4 is 0.9269 plus h is 0.02 into x4 is 0.08 minus y4 is 0.9269 square. Now you can calculate this by using calculator to get the value of y5. x5 is equal to x4 plus h. x4 is 0.08 plus h is 0.02. This is equal to 0.1. x5 is 0.1. y5 is 0.9113. Okay. So this is the answer. y5 is equal to 0.9113 and x5 is equal to 0.1. This is final answer. So in this way we can solve ordinary differential equations applying Euler's method. Today we are going to solve problems on ordinary differential equations applying numerical methods. Name of the method is Euler's modified method. This method is also known as Runge Kutta method of second order. So let us solve sum number 1. Solve dy by dx is equal to x plus y with x0 is equal to 0, comma y0 is equal to 1 by applying Euler's modified formula for number 1 x is equal to 0.05 and number 2 x is equal to 0.1, correct to 4 places of decimals. In this problem, this is differential equation dy by dx is equal to x plus y and initial conditions are x0 is equal to 0 and y0 is equal to 1. Means value of y at x is equal to 0 is 1, and we have to apply Euler's modified formula. So first of all we have to prepare a table. Table will be like this: x and y. Here x0 initial value of x is 0 and y0 is 1. Then we have to find out x1 at x is equal to 0.05. So let us find this y1, and then x2 at x is equal to 0.1. we have to find out y2. Okay. Now Euler's modified formula, that is nothing but Runge Kutta method of second order. In Runge Kutta method of second order, we have to find out two algorithms. Number 1 k1 and k2. Before that, dy by dx, we can express this as dy by dx is equal to function of x comma y, and here which is given by x plus y. Okay. Now we have to find out k1. Formula for k1 is h into f of x0 comma y0. h is difference between any two consecutive values of x. Initial value is 0, x1 is 0.05. So difference between these two values, that will be 0.05. Hence h is equal to 0.05. Now f of x comma y is x plus y. So this can be written as h into x0 plus y0. Replacing x by x0, y by y0 here. On right hand side x0 plus y0. Now x0 is 0, y0 is 1. Put these values here. That gives value of k1. h is 0.05 into bracket x0 is 0 plus 1 and this is equal to 0.05 into 0 plus 1 is 1. So this is equal to 0.05. Value of k1 is 0.05. Let us find k2. Formula for finding k2 is given by h into f of x0 plus h upon 2 comma y0 plus k1 upon 2. So this becomes f of x comma y is x plus y. So this can be written as h into bracket x0 plus h upon 2 plus y0 plus k1 upon 2. Put the values. H is 0.05 into bracket x0 is 0 plus h is 0.05 divided by 2 plus y0 is 1 plus k1 is 0.05 divided by 2. And this is equal to, we can write 0.05 into bracket 0.05 divided by 2 plus 0.05 divided by 2, that becomes 0.05 plus 1, that is equal to 1.05. Now calculate this by using Calc. Then this is equal to 1.05 into 0.05. We can calculate this 1.05 into 0.05. This is equal to 0.0525. Okay, this is value of k2. And now value of y at x is equal to 0.05, that is nothing but y1 is equal to y at x is equal to 0.05. This is equal to y0 plus initial value of y plus k2, and this is equal to y0 is 1 plus 0.0525, and which is equal to 1.0525. This is y1. Now we can put this y1 in table. X1 is 0.05 and y1 we have obtained, that is 1.0525. Let us find x2. x2 is 0.1. We have to find out value of y2. Initial value considering x1 and y1. Number 2, when x is equal to 0.1, and here we have to consider x0 is equal to 0.05 and y0 is equal to obtained value. Y0 is nothing but y1, which is 1.0525. Okay, once again we have to find out k1 and k2. k1 is equal to h into f of x0 comma y0. So, and f of x comma y is x plus y. So k1 is equal to h into x0 plus y0. But here x0 is 0.05 and y0 is 1.0525 and h is 0.05. 0.05 plus 1.0525. You can calculate this by using Calc. So 0.05 into bracket 0.05 plus 1.0525 bracket close, and this is equal to 0.055125. Okay, this is k1. Let us find k2. k2 is equal to h into f of x0 plus h upon 2 comma y0 plus k1 upon 2. So this can be written as, since f of x comma y is x plus y, this function can be written as h into bracket x0 plus h upon 2 plus y0 plus k1 upon 2. Put the values. So this is equal to 0.05 into bracket x0 is 0.05 here plus 0.05 divided by 2 plus, now here y0 is 1.0525 plus value of K1 is 0.055125 divided by 2. We have to calculate this by using calculator. Value of this bracket becomes 1.15506 into this 0.05. Then after calculation, taking multiplication of these two numbers, K2 is equal to, we will get 0.057753. Okay. Here fourth digit is 7 and fifth digit is 5. So if fifth digit is 5 or greater than 5, then this 7 you can replace by 8. Hence K2 is equal to 0.0578. We want answer correct up to 4 decimal places. Now Y2 is equal to, that is nothing but here Y2, that is nothing but Y at X is equal to 0.1, and this is equal to Y0. Here Y0 is 1.0525, Y0 plus K2, and which is equal to 1.0525 plus K2 is 0.0578. 0.0578. Take its addition, that gives Y2, which is equal to 1.1103. This is solution of given differential equation, which is ordinary differential equation applying Euler's modified formula or Euler's modified method. Now we are going to solve problems on ordinary differential equation applying Runge Kutta method of fourth order. First sum is solve dy by dx is equal to xy with x0 is equal to 1, y0 is equal to 1 at x is equal to 1.2, taking h is equal to 0.1 by applying Runge Kutta method, or which is also known as Runge Kutta method of fourth order. Here we have to find out 4 algorithms: K1, K2, K3 and K4. First of all, we have to prepare a table, that table containing values of x and y. Now x0 is equal to, initial value x0 is 1, y0 is equal to 1, x0 is also 1. Now taking h is equal to 0.1, we have to find out values of y at x is equal to 1.2 also. Okay, so adding h in x0, that gives x1. x1 is equal to 1.1 and x2 is equal to 1.2. At x is equal to 1.1, y1, this value we have to find out, and x is equal to 1.2, y2 we have to find out. Okay, so first of all, to find y1, we have to find out K1, K2, K3 and K4. K1 is equal to, formula for K1 is h into f of x0 comma y0. But you know, dy by dx we have to assume as f of x comma y, and here f of x comma y or dy by dx is given by x into y. So this is x into y. Hence f of x0 comma y0, this can be written as x0 into y0. So this is equal to h into x0 into y0. Now put the values, since we know h is equal to 0.1, which is given in statement of problem. Put here h is 0.1 and x0 is 1 and y0 is also 1. So taking calculation, this is equal to 0.1. K1 is equal to 0.1 into 1 into 1, that is equal to 0.1, because h is 0.1, x0 is 1 and y0 is also 1. Let us find K2. K2 is equal to h into f of x0 plus h upon 2 comma y0 plus k1 upon 2. So this is equal to h into f of x0 plus h upon 2 comma y0 plus k1 upon 2. Using this function, f of x comma y is x into y. So this can be written as x0 plus h upon 2 into y0 plus k1 upon 2. Now put the values. So this is 0.1 into bracket, x0 is 1 plus h is 0.1 divided by 2, bracket close, into bracket, y0 is also 1 plus k1 is 0.1 divided by its calculation 0.11025. Let us find K3. K3 is equal to, formula for finding K3 is h into f of x0 plus h upon 2, comma y0 plus k2 upon 2. But dy by dx is equal to x into y. So k3 can be written as h into x0 plus h upon 2 into y0 plus k2 divided by 2. Put the values and calculate by using calculator. So this is equal to h is 0.1 into bracket x0 is 1 plus 0.1 divided by 2 into y0 is 1 plus k2 is this one 0.11025 divided by 2, and after calculation this is equal to 0.11079. Let us find k4. Formula for k4 is h into f of x0 plus h comma y0 plus k3. Formula for k4 is different from k1, k2 and k3. Okay, here x0 plus h comma y0 plus k3, and then f of x comma y is x into y, so this can be written as h into x0 plus h into y0 plus k3. Now put the values. H is 0.1 into x0 is 1 plus h is 0.1 into y0 is 1 plus k3 is 0.11079. Calculate this by using calculator. Then this is equal to, we can write 0.2211. Let us find delta y. Delta y is given by k1 plus 2k2 plus 2k3 plus k4 divided by 6. Put the values. k1 is 0.1 plus 2 into k2 is 0.11025 plus 2 into k3 is 0.11079 plus k4. k4 is 0.2211 whole divided by 6. Use calci and get its value. So this is equal to, we can write delta y is given by 0.1272. This is delta y, 0.1272. Let us find y1. y1 is given by the formula y1 is equal to y0 plus delta y, and here y0 is 1 plus delta y is this one 0.1272. So this is equal to 1.1272. This is y1. Put value of y1 in table 1.1272. Let us find y2 at x is equal to 1.2, means at x2. Let us find y2. Similar to this, we are considering this is sum number 1 for x is equal to 1.1. Now sum number 2 in the same problem, y at x is equal to x2. Let us find this value. In first part we have obtained y1 is equal to 1.1272 and at x is equal to x1. x1 is 1.1. h is, h is 0.1, which is given in the statement of given problem. Let us find k1, k2, k3, k4 and then find y2. k1 is equal to h into f of x1 comma y1, but f of x comma y is x into y, so this is equal to h into x1 into y1. h is 0.1 into x1 is 1.1 and y1 is 1.1272. Calculate this by using calci. k1 is equal to 0.1240. Let us find k2. k2 is equal to h into f of x1 plus h upon 2 comma y1 plus k1 upon 2. This is equal to h into x1 plus h upon 2 into y1 plus k1 upon 2. Put the values and calculate by using calci. h is 0.1 into x1 is 1.1 plus h is 0.1 divided by 2 into y1 is here 1.1272 plus k1 is this value 0.1240 divided by 2. Calculate this. So k2 is equal to 0.1368. Let us find k3. Formula for k3 is h into f of x1 plus h upon 2 comma y1 plus k2 upon 2. But f of x comma y is x into y. So this is equal to h into x1 plus h upon 2 into y1 plus k2 divided by 2. This is equal to, put the values, h is 0.1 into x1 is 1.1 plus h is 0.1 divided by 2 into bracket y1 is 1.1272 plus k2 is this value 0.1368 divided by 2. Calculate this by using calc. So k3 is equal to 0.1375. Let us find k4. Now k4 is equal to, formula for k4 is h into f of x1 plus h comma y1 plus k3. Formula for k4 is different from k1, k2 and k3. So putting the value of f of x comma y, f of x comma y is given by x into y. So this is h into x1 plus h into y1 plus k3. Now put the values. H is 0.1 into x1 is 1.1 plus h is 0.1 bracket close into bracket y1 is 1.1272 plus k3 is this value 0.1375. Okay. Now calculate this by using calculator. Then k4 is equal to, we have obtained 0.1518. Let us find delta y. Delta y is equal to, formula for finding delta y is given by k1 plus 2k2 plus 2k3 plus k4 divided by 6. Delta y is given by putting the values of k1, k2, k3, k4. k1 is 0.1240 plus 2 times k2 is 0.1368 plus 2 times k3 is 0.1375 plus k4 is 0.1518 and whole divided by 6. Use calculator and calculate this. This is equal to 0.1374. Now y2 is equal to y at x is equal to 1.2 and this is given by y1 plus delta y. But here y1 is, already we have obtained this value, y1 is 1.1272 plus delta y is 0.1374. Take its addition, that gives final answer y2. y2 is equal to 1.2374. This is final answer. Let us stop here. Thank you. Thank you for watching this video. Thanks.